This question is given in the just 2019 examination. The question is the energy spectrum of a particle consists of 4 states with energies 0, E, 2E, 3E. Let ZB of T, ZF of T and ZC of T denote the canonical partition functions for 4 non-interacting particles at temperature T. The subscripts BFC, that is BFC, corresponds to bosons, fermions and distinguishable classical particles respectively. Let y is equal to exponential of minus E by kT. Which one of the following statement is true about ZB of T, ZF of T and ZC of T? So this is the question given. So they said bosons, fermions and classical particles, right? So for bosons are indistinguishable, we cannot identify the difference between them. So let us consider how many states? 4 states now. So in 4 states, how many a particle? In 4 states, how many particles are there? Each state has 1 particle. So total 4 states. So total 4 particles. Let us take this as B bosons. Okay. So then fermions. Fermions are also indistinguishable particles, and let us take this as E. Okay. And then classical particles. These are what? These are distinguishable. Means what? We can identify each and every particle. So let us take this as A, B, C, D. Okay. So now they said 4 energy states with energies. Okay. So 4 states with energy 0, E, 2E, 3E. Okay. Now distinguishable. So this is the given thing, and so for bosons, the energy spectrum of particle consists of 4 states with energies. Let this. Let us fill the particles with from maximum energy. So maximum to lowest energy we will prefer here. We will prefer here to solve this question. Okay. So maximum energy is 3. So let's okay. So bosons are indistinguishable. So any number of particle can take place in any state energy level. So let us take all the particles in 3E. So maximum energy will be what here? Maximum energy. So 4 particles, 3 each for 3 energy. So here for bosons it is 4 3 is 12. Maximum energy will be, total energy is what? 12E. Okay. So for classical particles, okay, classical particles is what? Any number of particles can take place any. So in the maximum energy we can write all the particles. We can take all the particles here also. Maximum energy of classical particles is what? 4 3 is 12. 12E. Okay. Then fermions follow the Pauli exclusion principle. That means each state can have only 2 particles with opposite spins. So let's take this as up, down. So 2 maximum, 2, then remaining 2 are left. So next lesser energy. So 2. So here if we see 2 3 just maximum energy of fermions is given by what? 2 3 just 6E plus 2 2 is 4E is equal to 10E. Okay. So the order they gave is what? BFC, boson, fermion and classical particle. So energy of boson is what? It is 12E, and energy of fermion is 10 E, and energy of classical particle is 12 E, and they gave Y value, it is what, 12, so E exponential minus E by kT. And partition function they are asking now, so the value is what, G I summation I Gi e power minus Ei by kT. Since here degeneracy is not given, take as 1, so here e power 1. First boson is what, 12 E now, so here minus 12 E by kT. Okay, 12 for bosons. Okay, and this we can write, and so on. Here e power 12, and when we compare with this, so here is what, here 12 y in the place of y we can write here this e power minus e by kT, we can write y, so it is y power 12, and so on for boson. And partition function for fermions, it is e power minus 10 E by kT, and so on. So this will be y power 10, and so on. And partition function of classical particles is here, energy is 12E, so minus 12E by kT, and so on. So here y power 12, and so on. So if we see here the options, so they are polynomials in degree wise, so this is why polynomial. Okay, so respectively means what, in order. So for boson it is 12, for fermions it is 10 and 2, so 10, 12, 12. So this is what Z partition function of boson, fermion, classical particle. They ask this order, so answer is this 12, 10, 16. So our sorry, do we, options are not matching, right? So 12, 10, 12. So if we see here for boson and classical particles, it is 12 and 12, so this and these are correct. So according to this, A option is very near. Okay, so let's see where we did mistake. In fermion we are getting wrong, no? So here, okay, so we asked maximum, no? So for maximum we have to consider only maximum level, so it is to 6, it is 6C. Okay, 6C, 6, 6, and here it is 6. So our A option is correct.